Hi, Math 1030. This is Mrs. Bricky. This lesson is 8C, and it has so much overlap and similar topics as 8B, so it's really not a stretch, also not very long, so that's good news. So this lesson is about population growth kind of with the human population. So for a long time, the human population just kind of increased at a steady rate. But then the advent of agriculture brought a lot more rapid population growth. If you can grow food, you can support a larger population. The human population is estimated to have reached about 250 million around the year 1. And then by the year 1650, it had doubled to about 500 million. So it took like 1600 plus years for the population to double. Exponential growth really didn't set in the human population until about the Industrial Revolution. And at that point, we had, as a human race, developed a lot better agriculture to grow more food. There were also a lot of improvements made in medicine and health sciences, which lowered death rates. And then, the population growth just really took off. The world population is projected to reach 8 billion by about 2024, but it's really difficult to predict world populations. But we definitely have seen our population growth rate start to decline. Not that our population is declining, but that the growth rate of the population is declining. All right, so we're going to do a few calculations. The calculations that we're going to be doing today are using exactly the same formulas that we have been using in 8B. So we're going to use the doubling time approximation formula where we take the number 70 and divide it by the percent growth rate. And then we're going to be using the formula for the new value to make some predictions about future population numbers. So here we go, example 1. The current annual growth rate for the world population is 1.1%. We're going to find the approximate doubling time for the world population and then make a prediction of the world population in 2060. So first, that doubling time. So the doubling time formula tells us that we need to take the number 70 and divide it by our percentage growth, so 1.1. So if we do that, we get 63.6. We want to round those to the nearest year, so we're going to say that our doubling time is 64 years. Second part wants us to predict the world population in 2060 based on a 2017 population of 7.5 billion. So the first thing, we just calculated doubling time. So we have this part of the formula, that's going to be the 64, but we need to figure out our time frame here. So we're going to have to do a little calculation to get t. Just a little subtraction. We need to know how many years we are talking about the passage of. So we start with our prediction year, 2060, and we subtract the initial year. So this is prediction year, subtract the initial year, or the year that you're given the population. So if we do that subtraction, we have a t value of 43. So we're talking about a 43-year time period. Okay, so now we can do our calculation. So the predicted population is going to be equal to that given population of 7.5 billion, and we can leave it in a decimal form like this, 7.5 times by 2 to the power of our calculated t-value 43 divided by our calculated doubling time, which was 64. 7.5 times 2 to the power of 43 over 64. And we use our calculator and we get 11.94. I believe on all of these it'll have you round that new population to the nearest tenth. And that was, of course, in billions. 11.9 billion. You'll have, I think 4 homework problems where you need to do this. On some of them, it will make you input the doubling time as part 1. On some of them, it will just jump straight to the predicted population, I think. But in all cases, you do have to calculate the doubling time, and I believe on all of them, you do have to do this calculation of t, the number of years that have passed. So don't forget to do that little subtraction. Okay, what determines the growth rate of a population? Well, the overall growth rate of a population is determined by both the birth rate, or how many new members of the population you have, but then you have to subtract away the death rate, or how many people have died. So you can do a quick subtraction to get that overall growth rate. So for example, in 2017, the global average was that there were 19 births per 1,000 people, but there were 8 deaths per 1,000 people. So the overall population growth rate was 11 per 1,000 people, which is where that 1.1% number comes from. So we're going to do a couple of calculations based on a little chart of birth and death rates. So my example here is focusing on country A. Be careful on the homework assignment. It may give you country B, it may give you country C, it may give you country D. So just be watchful for that and make sure you're using the right row on the table. So we want to calculate the net growth rate for a couple of different years. Our first year is 1985, and again, we're working on with country A. So in 1985, the birth rate was 13.6, and the death rate was 11.9. So the net growth rate, or the overall growth rate, is 13.6 births subtract 11.9 deaths, which gives us 1.7 per 1,000, or a 1.7% growth rate. Country A in 1995, so it's kind of having us investigate this over a few years. In 1995, the birth rate was 10.9, and we need to subtract the death rate of 11.5 to get the overall growth rate. 10.9 minus 11.5 is negative 0.6. Now, negative here means that the population is actually declining or getting smaller. And then finally, we need to look at in 2003. So in 2003, we have a birth rate of 9.4 and a death rate of 11.3. And that gives us an overall population growth rate of negative 1.9. So once you do these 3 calculations, it'll ask you if, based on these trends, how do you think that population is going to change in the next 20 years? So in this case, because our growth rate it's getting lower and lower and lower, and it's negative most recently, we would probably predict that the population is decreasing. If these numbers were positive, we would probably predict an increase. So let's see, I'll write that down. So positive growth rate, you would predict an increase. If that growth rate was close to 0, that's when you would predict that the population would remain the same. So negative means decrease, positive increase, close to 0 is remain the same. Okay, let's see. There's some notes about carrying capacity and real growth model, but I realize now that they have taken those questions off the homework, so I'm gonna skip past this because, you know, it's not on the homework anyway. It's kind of interesting if you want to read it. There is one homework question that asks you how today's birth and death rates compare to those in the past, and why is the human population growing. So this is just informational, but it is one of the multiple choice homework questions. Birth rates have decreased along with death rates. So in our world right now, both the birth rates and the death rates are decreasing. However, human population is still growing because the death rates have fallen even more dramatically than the birth rates. So the human population is growing, just not growing nearly as quickly as it has in the past. So as always, let me know what homework questions you have. I am more than happy to help if you send me a text or email. If I don't get back to you right away, it could be because I'm cooking dinner or making a video or something, but I will get back to you as soon as I can, and I am trying to watch those pretty carefully. So let me know what you need. Thanks a lot.